And it's streaming now. Oh wow, so it was lying to us. You should not drive. You should not drive or be distracted while doing this. Not relative to each other, though. We're hurling away from each other because the whole expansion of the universe thing. We're getting bigger. We just don't feel it. Yeah. You got away with the word most. I'm impressed. Instead of the word all. Well, you're... Oh, geez, it's just been one of those. Actually, I had to turn two boards, not had to, but I turned two boards, one to JLC PCB, using, and they kicked it out. I was glad they kicked it out. I don't even know where to do that. I haven't had to do that before. Hang on. I have a... Oh, I'm broadcasting. Yeah, I forgot that I'm... Give me a second. Ah, I did not know that you had to do that. Okay. Set up a new... Source. Oh, a source. Got it. Okay. Audio source. Bear with us, everybody. This is what happens when you do something live while somebody's in an RV. And I don't have a source listed for you. Where is it normally? Streams? But see, I hear you in everything. Okay, hang on. Now it is pulling it from your video. Let me try your other Skype active speaker. Ask him now how it works. No, there's three different Skype channels, and one of them was the screen capture, but you're not screen capturing today. So, yeah, I have three different Skype things to choose from, and if it works, then it means it chose the wrong one originally. If it doesn't work, it means I'm still a host. So when you talk to me, you always put in an audio source? And that's what I have also, yeah. Yeah. I say, oh, I don't know. I was going to say I'd rather not experiment on the air. And then nobody will want to watch us again, right? I did, and I can't get them to play where you can have any control whatsoever over them. They just start streaming, and then they start over again when you select the key, and there's no way to index into the middle of it or anything. So we'll have to do that live sometime. So, right. So if I were to show what I showed a little bit last time, let me get one more thing going here. Because I did do some PC board stuff this week, now that you mention it. All right, so I'll just show it in front of the camera because we're not prepared today. So basically what I had was this little carrier board. I've got a circuit board made by Trends out of Germany or Austria. It says Germany, but somebody said they're from Austria. And it's got a Cyclone 10 LP on here, which is just a Cyclone 4 rebranded, it turns out, by Altera. And I've had a heck of a time with Altera's software these days. I've been trying versions 18, 19, 20. I had to go to 17 just to get it to work. And their problems are all in their scripting tools, their TCL scripts, which is a stupid way to have good software and then blow it at the last minute. The scripts trying to create model simulations have problems where they're inserting leading backspaces, which don't interpret on Windows the same way it does on Linux, guys. So knock it off. I had to go in and hand edit batch files, do files, tickle files, all kinds of things. So I've got it simulating a little bit. And the idea is that this 3 volt, actually a 1.8 volt, 3 volt tolerant FPGA, when plugged into a carrier board, here's a blank. And this is the older one. I was only buffering some of the signals. But when plugged into one of these, suddenly, instead of a 1 megahertz 6502, I've got up to 32 megahertz 6502, and it's got 64 kilobytes of RAM on it. 0 wait state, 32 megahertz RAM. So what this means is you plug this into a computer, and the processor would be useless if it only ran at a megahertz, even though it's capable of 32. Well, everybody asks me, why didn't you go faster on like 128s and stuff, C64s? And the answer is the memory bus didn't support it. It's like balancing a pan of water. Nothing can go faster than anything else, or the water is going to slop out of the pan and everything gets wet. So the memory bus was limited to 2 megahertz, of which the graphics processor got half of that, and the processor got 1 megahertz. But if it goes to memory inside, it goes, oh, that's inside. Let's go ahead and get that for you. Boop, boop, 32 megahertz, 0 wait state. This will keep running at 32 megahertz as long as the memory is it's hitting internal memory. When it sees the code that says, oh, now you're going to the outside world, it'll suddenly halt and wait for an outside world 1 megahertz cycle to occur. And then it'll either do another 1 megahertz or go back to 32 megahertz. So, and this turns out to be a great test for the Altium AutoRouter. So Ben, if you tell me what you found in the AutoRouter, first off, I'll repeat it for everybody to hear. But did you experience that issue I had with the AutoRoute by Net class? Did you try that? Ben's saying it worked. And that's why I tried to do it by netclass. Ben said that it does work, which of course it works. It just means I'm not working it correctly. But when I tried to route by netclass, it wasn't working the same as if I auto-routed the whole board. And I wanted to auto-route by netclass because I didn't want it touching the power leads, right? Humans are smarter than auto-routers when it comes to power leads. I'll tell you that the Altium AutoRouter is probably smarter than me when it comes to just straight up routing. Not smarter than Ben, but smarter than me. Ben's nodding in agreement, everyone. He's not driving, folks. He's typing, not driving. He would not do both of those at once. So are you sitting in a parking lot in Utah? Is that what you said? So when we come back, we'll be better prepared to show an auto route and actually interactive route, which is Altium's strength. Right? And quite simply, I'm not good enough at it yet. Okay. He's got his laptop, folks. He's saying he'll do it live. So this is, I'm saying everything twice for you. So you just keep talking. Don't worry when I step on you, because they can't hear you, so they don't know I'm stepping on you. The way Ben would normally do it is to set up pre-route power and ground. Yep. Which I did a good job at. I'm an expert at that. No. Plus, you can get... And that's how I started saying when I routed this board this week, what Ben had said is vias don't cost as much as they used to. And I take that to mean physically they don't cost as much in what they do to your signal, because we're doing better jobs of making PC boards. But also vias can be made smaller than they were not too long ago. I'm not talking micro vias. From JL PCB, I was able to get an 8mm drill. I had to go to an 18mm annular ring. So that was the thing. I needed 8 and 8, so I rounded up to give it a full 10. And what that means is an annular ring and a drill, the drill doesn't have the same tolerances as that copper we're trying to hit. And the copper around the drill is called the annular ring. Well, we need to allow that drill bit to wander around in there a little bit. Excuse me if that's the signal for, But Ben, would you agree with what I just said, that we need to let the drill bit wander, and that's one of our looser tolerances in the world? Right, and so Ben's now talking about teardrops, which look like they're for electron flow, right? Well, two things. Remember, it's not usually about electron flow. It is in switching mode power supplies sometimes. But the other thing is, that's just statistically makes it so if the drill wanders in one direction, you got some slop, but there's still all these other directions it doesn't help you in. But you know what's up with teardropping is it looks cool. We thought it was cool. Breakout. So Ben's talking about the breakout. If you have what Ben just said is in that direction of here's your hole and here's your trace, you don't want the hole to move in the direction of the trace because it could actually cut the trace, what's called a breakout. And so the teardrop actually, and so I'm actually learning something now. I knew it, but I forgot it. But the teardrop does help in a vital direction, so it's not near as random as I like to say. With that said, it's still random. So back to using routing technology. Okay. Ben tried the board a couple ways. Oh, I didn't know that. So when I auto-routed, what Ben just said was active route won't change layers and add vias for you, which I did not know. Go ahead, Ben. So you have to do your fan out. So the human still has to be intelligent about the architecture of how you're going to fan out especially. Is that a good way to summarize it? And you probably use rooms and rooms for that too. So what Ben just said to do is to break out your, or fan out your power and grounds first, and then to use it for your signals. And that is the order I tend to do it in also. I just don't have Ben's and my friend Terry Fisher, I don't have their experience doing breakouts. Because if I were to have to do a 1,000-pin BGA right now, it'd mean I'm not working at the right place, because I'm too small for 1,000-pin BGAs here. So, so you were saying then that, or one of the things I wanted to say then is when I did the active route where I threw the whole board in, it aggressively changed layers, found all the ways, and I saw it doing rip-ups, right? The rip-up is where an AutoRouter says, that's good, I'll give it a score, but then I'm going to rip it up and I'm going to try and route a different way, and I'll score that too, and then I'll take the best score. And a good AutoRouter doesn't get torn up on just one of those routes. It looks at everybody's scores and says, oh, 400 of these scored better doing it this way than doing it this way. And that's why AutoRouters are complicated. So, but what happened when I ran it in AutoRouter mode, it completed this board. Actually, I have a more complex one of these I'll have to show with fine line, 40 mil centers. It completes it, whereas when I did an auto route by net class, it did exactly what you're saying. It only did the ones on the same layer. It didn't aggressively go, oh, and from the bottom and from the middle. I even repurposed one of the, there's no power on here to speak of, so this is really 3 signal layers, 1 ground plane, which violates rules, but what do I care? I'm the boss here, right? And if the electronics works, now that's why I said I routed the VCC and ground really well, because I have a lot of experience in 2-layer boards where that's all we had. And part of the technique there is to do it in a grid so that you don't end up with interdigitated where ground comes from one way and power comes from the other way. Nah, no good. Power and ground need to come from both ways. So Ben's saying he made a promise to Ian, and Ben wants to talk about rooms for Ian now. That's a shame we can't hear you directly here. And I'm afraid to keep messing with the sound, because then maybe we'll lose my sound in the process. So, how about this? How about rooms are very useful for routing. Yep, I agree. So to connect down to a BGA, we use a room, and it knows when it crosses into that room, and now new rules apply, including neck down rules. So what's a neck down, Ben? So you get to break a rule, basically. You can go down narrower, and you're exchanging the statistics of that narrowness for, hopefully it doesn't break right there where it gets narrow, but that's the only way we can route some of these parts, right? How narrow have you gone? Three? Okay, so Ben has seen designs down to 3 mils. He doesn't get into them himself much. And you'd have to be a specialty company with a special relationship. I shouldn't say specialty company, but you know what you're doing, and you've got a relationship with a PCB vendor before you go playing around in 3 mil. Is that a good summation? Yield and cost, yes, as Ben just mentioned. Yep. So Ben is saying that next week for Ian, sorry, he's going to have his laptop set up and he'll show you the rooms. He doesn't have his laptop set up just right now because he's actually in a driver's seat in a parking lot in Utah. But somewhere he'll be in a campground with his laptop in the back of an RV, and he'll show you rooms, and we'll do the we'll do all the routing and stuff. So, all right, I'm going to say. Yes, you do, and I think we've stretched. Ben just said he's got to hit the road. We've stretched everybody's patience with our lack of audio, and I'll apologize for that. And we'll see you here next week for the Coriolis effect, right? And you'll be somewhere in Montana. Where will you be? Southern Utah. He likes Utah, folks. So, his first time. And Utah likes him. So, well, thank you, everybody, for putting up with us. We'll catch Ben from the road next week, and we'll have some more shenanigans. So, take care, everybody. Yeah, we'll test our audio before ahead time. All right. All righty. Bye, everyone.